A warm greetings to all the viewers. I, Miss Flora Dani, Assistant Professor, Department of Civil Engineering, St. Saviour's Catholic College of Engineering. In this video, I will be giving an introduction and a discussion on the topics connected with the subject soil mechanics. So come, let's get started. Slide 1 is Introduction to Soil Mechanics. Soil mechanics or geotechnique is one of the youngest disciplines of civil engineering involving the study of soil, its behavior, and application as an engineering material. So, according to Tersahi, soil mechanics is the application of laws of mechanics and hydraulics to engineering problems dealing with sediments and other consolidated accumulations of solid particles produced by the mechanical and chemical disintegration of rocks, regardless of whether or not they contain an admixture of organic constituent. Hence, the soil mechanics find its application in foundation design, slope stability, earthworks, and retaining structure. Soil is a natural unconsolidated material composed of solids, water, and air, and hence we call soil as a three-phase system. Generally, the term soil has its various meaning depending upon the general professional field in which it is being considered. To the perspective of an agriculturalist and a geologist, soil may seem to be different, but to an engineer, soil is an unaggregated or uncemented deposit of mineral, of organic particles or fragments covering large portion of the earth's crust. So it may vary in names like boulders, sands, gravels, clays, and silts based on its particle size. So, understanding the soil behavior is essential in civil engineering for a safe and cost effective design. The next slide is about the soil formation, how the soil is formed. Soil is formed by weathering of rocks. Weathering is the disintegration or fragmentation of rocks. So this disintegration or fragmentation may be by three means, or we have three types of weathering. First one is physical weathering, second is chemical, and next is biological weathering. So the physical weathering was also known as mechanical weathering because the physical weathering takes place by mechanical process. The mechanical processes include freeze and thaw, abrasion, temperature change, salt hydration, pressure release, salts mineral growth. So on having all these mechanical processes, the disintegration and fragmentation of rocks takes place and there will be no chemical alteration. So, weathering takes place by means of mechanical processes termed as physical weathering or mechanical weathering. The next one is chemical weathering. Here in chemical weathering, chemical reaction of minerals, water, and air takes place. So the chemical processes include oxidation, hydrolysis, carbonation, hydration, dissolution. So all these chemical reactions may lead to chemical weathering. So here what happens is chemical alteration of minerals takes place and soil is formed. So soil formed by these types of weathering is termed as chemical weathering. And next is biological weathering. So here the living organisms or living things is involved. So include physical and chemical actions of fungi, organisms, plant roots, lichens, moss, and everything. So all these biological agents may lead to disintegration and fragmentation of rocks, which we call it as biological weathering or biological disintegration. And after weathering, we have two types of soil based on the position or location of those soil. If the soil is present in the place where it is formed or it is present in its parent rock, it is termed as residual soil. If the soil is transported to some place by some means, it is termed as transported soil. Say, if the soil which is formed or which is weathered is transported by means of water, we call it as alluvial soil. If it is transported by means of wind, we call it as alluvial soil. If it is transported by means of glaciers, we call it as glacial soil. And if it is transported by means of gravity, we term it as fluvial soil. This slide explains the soil problems in engineering. As we know, all the structures are built above the soil. So if there is a problem in the underlying soil, it completely affects the structure. So say if the soil is expansive nature or if the soil is an expansive soil, the clay soils they become swell and shrunken when moisture changes and this leads to cracking in building. Next, if the soil is a collapsible soil, loose dry soils will compress suddenly when it gets wet. So this may completely collapse the structure. And next is organic soil. If the underlying soil is an organic nature, because of its high compressibility and low strength, the complete structure get damaged. Next, if the soil is of erosive nature, this may lead to instability and sedimentation issues. If the soil has liquefaction effect, sudden loss of strength during earthquakes takes place in the saturated zones. So all these stated problems may lead to the complete disintegration or uh, collapse of the structure. Hence, the proper care or proper knowledge about the properties and behavior of the soil is required. The next is physical properties of soil. So the physical properties of soil includes grain size distribution, soil texture, consistency limits, moisture content, specific gravity, and soil structure. All these physical properties is the key to find whether the soil is fine grained or coarse grained, or to know its texture, to know whether it is in liquid stage, plastic stage, or shrinkage stage, the arrangement of its particles, its specific gravity. So, by knowing all these physical properties, we could analyze or categorize a soil as a particular soil. The next is the phase relationship in soil. The soil has three phases. The three phases include soil solids, water, and air. So when we consider a soil system, the soil system has the solid, liquid, and gas. If a soil system has all the three phases, that is soil solids, water, and air, then we call it as partially saturated soil. Or in a case if the soil has only two phase, that is the soil system has only soil solids and liquid water, then the system is termed as completely saturated soil. In case if the soil system has solids and air alone, then it is termed as dry soil. So based on the presence of these components, solid, liquid, and gas, we name it as partially saturated soil, completely saturated soil, and dry soil. So the next is key relationships. So before knowing the key relationship, we first have to know. See, consider this as a complete system, three-phase system where solid, water, and air is present. So here all the three are present. So we call it as three-phase system or a partially saturated soil. Here the complete volume is termed as capital V. The solids present, the volume of this solids alone is termed as Vs. And the volume of this air and water together is termed as Vv. The volume of this water alone is termed as Vw. So while considering the key relationship, first we have is the void ratio. So the void ratio is the relationship between Vv by Vs. Vv is the volume of this voids divided by the volume of soil solids. The next is the porosity, and the porosity is the relation or ratio between the volume of voids to the total complete volume, which includes the solids, water, and air. And next is the degree of saturation. So this degree of saturation is the ratio of volume of water to the volume of complete voids, VV. And for water content, we do not consider its volume, we consider the weights of the water and the solids present in the complete system. So here, so we will finding the water content, we have volume of water to, sorry, weight of water to the weight of the solids. And next is unit weight. So here unit weight is defined as the ratio of weight by volume, weight divided by its volume. So while we consider the bulk unit weight, we have to consider the soil as partially saturated soil. So while considering the dry soil, we consider the dry soil. For saturated unit weight, we consider a soil is completely saturated. And for submerged unit weight, we do take the submerged soil weight. And so why these key relationships are important is they are essential for knowing the processes like compaction, consolidation, and shear strength analysis of the soil. So hence, we have come to the end of this video. If you have any doubts, you can post your questions in the comment section. Or if you need any clarity, or if I want to explain any topics in detail, you can mention that in the comment section. Okay. Thanks for watching. Please check our updates to know more about the topic. Thank you.